Today we're going to be doing Book 3, Proposition 10. So the enunciation is, a circle does not cut a circle at more points than 2. So we're given 2 circles, circle ABC and circle DEF, and then the points B, G, F, and H. And then we're trying to prove that, like I said, like the enunciation said, that the 2 circles, circle ABC and DEF, do not cut each other at more than 2 points. Okay, so I'm going to draw our other given circle, DEF. So there's point B, G, H, and F. Then up here is A, and then B, and down here C. So the first thing we're going to write over here, our statement, is that circle ABC that circle ABC cuts circle DEF at points B, G, H, and F. And then our reason for that is that that's an assumption. This is a reductio ad absurdum proposition. Okay, so the first thing we're going to do is we're going to connect, I have those two, need to switch those. We're going to connect BH and BG. So we connected those, and that's postulate 1. You can connect 2 points in a straight line. And so the next thing we're going to do is it says to bisect BH from point A at a right angle to BH. So we're going to cut it like that through A to C. And that there's point D from the circle DEF. And then E is over here. And so we said that not only did we bisect it, we bisected it at a right angle. So we bisected BH at a right angle. So that's Book 1, Proposition 10, that you can bisect a finite straight line, and also Book 1, Proposition 11, which is to raise a perpendicular line from a point. And so then we're going to do the exact same thing for BG. We're going to bisect it. We're going to bisect it at a right angle through point E. So we know that's right angle. Same exact reasons. Propositions 10 and 11 from Book 1. And that gives us the points N, M, P, O, and L. And so we bisected them. I need to fix it. We bisected them at a right angle. And then because of that, we also know that where it bisected it, it cut BH, AC cut BH into two equal lines, and then LM cut BG into two separate lines. And because of that, we know, well, let's start with BH. We know that the center of ABC is going to be somewhere on AC, because book 3, proposition 1, at the end there's a porism that says that in a circle, if you cut a line, here I'll read it. From this it is manifest that if in a circle a straight line cut a straight line into two equal parts and at right angles, the center of the circle is on the cutting straight line. So because we bisected BH with AC at a right angle, we know that the center of this whole circle, ABC, is somewhere on this line AC. So I'll write that, book 3, proposition 1, porism. And then we know the same thing about line LM. We know the center of ABC is on LM for the same exact reasons. We bisected it at a right angle in a circle, which is, once again, book 3, proposition 1, porism. And so we go to where the two lines meet, where LM and AC meet, which is going to be point P, so we know that point P is the center of circle ABC. So I'll put the same exact reason and also statements 5 and 6. And then if we do the exact same thing, but saying it's for circle DEF, so this one right here, for a circle DEF instead of ABC, we know that the center is going to be on LM and AC. So it's going to be, so the center of DEF is also, sorry, I need to write that right. Point P is the center of DEF. And so we'll just put similarly. And so therefore we know that P is the center of both circles ABC and DEF. So I'll go ahead and write that. So therefore, P is the center of circles ABC and DEF. But we know from book 3, proposition 5, that that is impossible. So circle ABC and DEF cannot have the same center. Like I just said, that's because of book 3, proposition 5, that says if two circles cut each other, they cannot have the same center. So we're going to draw our little arrow, and that's reductio ad absurdum. And then I ran out of room, so QED. There's proposition 10.